All right, so we're going to do a quick review here. The first question on your handout from the substitute on solving a system algebraically using substitution, where you substitute or plug in an expression to represent the letter. So you have a system here because you have two equations, a group of equations. The first one says 4x plus 7y equals 19. Second one says y is the same as x plus 9. So if I look at that second one, y is the same as x plus 9. So anywhere there's a y, I can substitute or plug in x plus 9. So if I go back to that first equation, there is a y times 7. So I'm going to rewrite that equation, but instead of y, I'm going to use the substitute of x plus 9. So that top equation is now 4 times x plus 7 times the substitute for y, which is x plus 9. So y, 4x. plus 7 times my new y, the substitute, and that equals 19. By substituting that expression in, I now have an equation with one letter. I can solve this. I'm going to start by distributing the 7. So I have 4x plus 7x plus 63 equals 19. Okay, then I'm going to combine like terms. So there are 11 x's here plus 63. That's going to equal 19. If I go back to x, there's times 11, there's plus 63. I'm going to get rid of the addition first with subtraction. So that cancels. I have 11x. That's going to equal negative 44. So if I go back to x, I'm going to divide both sides by 11, and x will equal negative 4. So far I know my solution. So the solution is always an x comma the y. The x is negative 4. Now I want to go back and find the y value. So I'm just going to switch my colors. So now I can pick either equation. Definitely think the bottom one's easier. So if I use y equals x plus 9, x is no longer this unknown number. We know it's worth negative 4. So y is equal to x, which we know is now negative 4 plus 9. So if I add those two together, y must be 5. So if I were to graph this system of equations, they would intersect at negative 4 comma 5. So now I want to go through and check my answer. Is negative 4 comma 5 really the point of intersection? If it is, I can plug in negative 4 for x and 5 for y into each of these, and it would be a solution because it would give me a true sentence. So if I take the first equation, if I plug in negative 4 for x and 5 for y, does that equal 19? So you can just go to your calculator and type that chunk in. I'm going to go to the pieces because I don't really have mine handy. Negative 16 plus 35. So they are not different signs, subtract. So let's see here. I gotta do a little math on the side. That would be 19 equals 19. So yes, that is a solution to the first equation. And now I'm going to take y equals x plus 9. I'm going to plug in 5 for the y. Does that equal negative 4 plus 9? And yes, 5 does equal 5. So if it is a point on the second line and a point on the first line, it is that one unique point on the second line. All right, so going forward, you're going to work on the other 3 questions in this packet on your own. There is some graphing and there is some more substitution. So take your time, go carefully, lots of parts and pieces to these, but this will get turned in.